Hi, you tens. We're going to just go through your self-directed task on parabolas. And I'm just going to give you a few hints which hopefully can help you in doing this as efficiently and effectively as possible. Now, first of all, we're going to be looking at exploring parabolas in the form y is equal to ax squared. So over here, we're going to be looking at the coefficient of x squared for these. Now, when you're going to sketch these, you'll need to sketch these in your CAS calculator. Just so you know, if for whatever reason you don't have access to your CAS calculator, I don't know why that would be, then there are other options. For example, if you go to Desmos, and you can then type in x, that's a graph of y equals x, and as you can see, we can go up to here, x squared. Let's just say x squared plus 7x plus 12. Now, if I was to factorize that, you might recall that I need two things that multiply to give 12 and they add to give 7. What are they? 3 and 4. Now, let's think about this just for a second, because there is a reason why we've been doing all of this factorization, isn't there? There is a reason. And that reason is that, and if I were just to write it down here, if I have the graph of, let's add a page. If I had the graph of y is equal to, that's not going to help me. If I have a graph of y is equal to x squared plus 7x plus 12, then hopefully we identified that we can factorize that, x plus 4, x plus 3. Now, of course, for y-intercept, we know that we can let x equal 0. What about for the x-intercept? What do? The x-intercept, we let y equal 0. Now, if I was to let y equal 0, then we're using the null factor law to solve this equation. What are my two solutions? X is equal to -3 and -4. Now, if x equals -3, -4, what is that? They're the x-intercepts, aren't they? So, if I was to now go back to my calculator, hopefully you can see that, well, I've just sketched this on Desmos. You can see there that -4, x-intercept, -3. Halfway between those intercepts, which we'll look at a little bit later, is what we call a turning point. Okay, and we'll look at that a little bit later. And of course, you've also got your y-intercept over here. So that's on Desmos. You can do that absolutely. Likewise, you can also do, if I was to go across here, you can also add another function. And let's just say we've got this other form which we'll look at later, something like this. But can you have a look? Let's just quickly have a look at something like this. X minus 3 all squared plus 1. If it's in this form here, where we've got in a bracket squared. Oh, okay. Did it run out, did it? No, I put the paper on the down. Okay, well, we'll get some more. That's okay. Thanks, Jazz. So, as you can see here, let's have a look. This parabola, let's have a look. This 3, can you notice over here, if I move this across 1, 2, 3, there's my x part of the turning point, and it actually goes up 1. Can you see there that it turns at the coordinate 3, 1? So there's this relationship between this form here. This form here is what we call turning point form, and we're going to identify sort of how that works. Basically, we've got a parabola which turns, and the turning point is at 3, 1. Now, if I was to go now to a CAS calculator, how would it look? Well, we've got to go to the home screen, okay, and then we've got to go over here. Now, we're going to go to this graph screen over here. Now, the first thing we're just looking at is just the effect of what A does, ax squared. So 1x squared, what is the graph of 1x squared? Well, it is a graph which goes through the origin, turning point 0, 0, and you can see there it looks like this. What about now, by the way, if you want to add a graph, you don't have to do it all in separate graphs. You just press the tab button. Brings up F2 of x when you press tab button. And then let's just say if I've got 2x squared, what do you notice? It probably come up in red now. Notice that it goes through the same turning point. But what has the 2 done? Has it made it fatter or thinner? It's made it thinner. If I was to do 5x, press tab, and if I was to go 5x squared, and you can see there that there's my 5x squared, it's made it thinner again. Now, this is going from 1, so as I'm going up in values of A, it's actually making it thinner. However, what about if I go down, and if I look at a fraction, instead of 5x squared, what about 1 over 5x squared? So we're talking about it's less than 1. Well, if values of A get larger, it makes it thinner. Maybe if we're compacting it, maybe it's getting, for example, let's do this. Let's do control and divide, and let's do 1/5 x squared. Do you think it's going to make it thinner or fatter? Fatter. Can you see there that the pink one is 1/5 x squared? And of course, if I was to go even smaller than 1/5, like if I was to do 1/25, it's going to be even wider again. There you go. There's that green one. It's made it quite very wide, hasn't it? All of these have the same what we call parabolic shape, but as you can see, all of these things are going to affect it. Now, what do you think is going to happen if I was to go tab and I started off with, by the way, the blue one was x squared. What do you think would happen if I do a minus? Now, when you do a negative, you can't do this negative here. If you do that negative there, I don't think it'll work. It works on these calculators, it never used to. I want you to use this negative here. It actually does work, but just be careful. If you've got a negative in front, I use that negative. Negative x squared is this orangey looking one, this brown one now. You can see there. What does it do? Well, it's actually reflects it in what we call the x-axis. It's reflection. Okay, so all of these things are impacting what happens. So I want you to clearly just, when you do that, fill in the gaps, make sure that you're filling in accurate graphs of where the turning point is and you know where the intercepts are, okay, because you can see that all on the graph. Now, we then give you a bunch of these things. Well, hey, which one's which? Fill in the blanks. Which one is number 4? Well, number 4 clearly would be, it's one of the wider ones. So number 4 here, if I was to look at number 4, which one do you think number 4 would be? That pink one. So negative 1 over 20x squared. Yeah, because we've only got 2, and the negative 2x squared would be much thinner, wouldn't it? So clearly that light blue one there would be negative 2x squared. Okay, and likewise 2x squared would be that blue one because it's the same thickness as this, but it's just inverted. Okay, so as you can see, now then what we want to look at is what are the effects of A between 0 and 1. So those are the ones that made it wider, etc., etc. Okay, so I want you to use this word bank to basically fill in and complete that. Pretty straightforward. Okay, if you can sketch them, it should be fairly obvious. Likewise, now that we're then looking at graphs where we're basically adding some constant. So for example, I don't want that one on Desmos. I don't want any of that now. I'm going to go to a home screen and I'm going to go to a new document, and I don't want to save. I just want to get rid of that. If I go over to here to add graphs, well, the first one, x squared. Enter. Press tab, and then let's add another graph. We're going to now go, we want x squared plus 6. So x squared plus 6. You can hopefully, if you see something like that, and it's not ideal, we want to actually go menu, and we want to go to Windows Zoom. Let's zoom out a little bit because you can see that we're only going up to values of 6.67. So we want to do something along the lines of that, zoom out a little bit more. If you can't see part of the graph, just zoom out. That'll be enough though, because now we've got x squared minus 8. If I hit the tab button, let's do x squared minus 8. And as you can see, what is the minus 8 doing? What's minus 8 doing? It is the y-intercept is minus 8, but it's also moving every point down 8. So I guess the one point we're talking about, which is in particular quite interesting to us, is this turning point. this turning point here, this turning point right here, that point there is going down 8 places. Okay, that's what we call a transformation. Yes. So the question that we had was, if I had minus x squared minus 8, we would invert this, but we would still move it down 8 places. So let's do that. Minus x squared minus 8. You can see there, they are inverted, and there you go. There's minus x squared minus 8. You're going to have to do that for those ones and obviously sketch the graph. Then you've got to then fill out which one's which. Okay, pretty straightforward. Then finally, we're now looking, so we've just looked at some translations up and down. We've looked at the effect of what A does. Now we've got this other translation, which is actually in the horizontal direction, which is this x minus h business. Okay, now basically what I can say to you is, well, let's have a look. X minus 3 squared as opposed to x squared. If I was to go over here, let's get rid of all of this. Let's go home, go to a new document. No, I don't want any of that. And let's go back to the graph screen. If I go to x squared, we know what x squared looks like. But x minus 3 squared, in brackets, x minus 3 all squared, what does it do? Does it move it left or does it move it right 3? It moves it to the right 3, doesn't it? Now, a way to actually sometimes students get confused because they see a negative x minus 3 and it's moved it to the right 3. The way to visualize why that's doing that, think about it. What does x have to be equal for this bracket to be equal 0? What does x have to equal for this bracket in here to be? X would have to equal positive 3, wouldn't it? So 3 take 3 is 0. So in other words, it's moved it to the right, positive 3 places, okay? Now, what about if I was to do this? If I was to do tab and I was to go x plus 3 all squared, what do you think is going to happen there? It's going to move it to the left 3 places. Again, how do we start comprehending why that is? I guess my little shortcut is, what does x have to be equal for this to be 0? It would be negative 3. Now, what about, so there's those, and you'll have to complete those. And of course, again, if I put a negative out the front, for example, if I was to go minus and I was to go x plus 3 all squared, x plus 3 all squared, you can hopefully see that, hey, it's going to move it to the left 3, but it's also going to invert this. It's my little pink graph you can see there. What about then if I was to do tab? What's going to happen here? I'm going to do x minus 7 all squared, and then I'm going to add 5. What do you think is going to happen with that? It's going to move it how many places to the left or right? 7. It's going to move it 7 places to the right, and it's also then going to go 5 up. Boom. You can see it there. Now, of course, we've done it there. It's quite hard to see. Let's go to Windows. Let's go to Zoom. Let's zoom out a little bit. And as you can see there you go. Let's have a look. Now, by the way, so another thing that is beyond what we really should be doing now. Yes, hopefully you can see, if you get the right scale here, you can hopefully see it's not very good on this one here. But if I wanted to get what that turning point is, what we can do is we can go to menu, we can go to analyze graph, and you can see there that this little turning point, do you think it's a minimum or a maximum? Is it a minimum or a maximum? Think about the way it turns and what that bottom point is. Is that a minimum or a maximum? It's a minimum. See how it's like it turns? So let's go back. So think about the values of y. Okay, we've got big values of y. We're getting smaller and smaller and smaller. It then turns, and this point here, the minimum value of y is right there. Okay, so that's basically what we call a minimum turning point, this one here. So if I wanted to find the coordinates of that, I'll probably accept if you just did it and you had your graph to scale, then you could actually probably see, you could count these, you could actually count these little lines if you wanted to, but you know, and you can go 1, 2, 3, 4, 5, 6, 7. 7 is the turning point, and it goes up 1, 2, 3, 4, 5. There you go, it goes up 5 places. But what we could also do is we could go to Windows, Analyze Graph, find the minimum, and which graph do we want? You're going to have to select. So you're going to have to use your thing like a mouse, and you're going to have to go, I want that one. Click down on the little mousy thing, which is here, over here. Once you select it, click down on, so click that button, and then that will select that graph. Then it says it wants a lower bound. Well, basically, we've got to pick a point to the left, press the mouse button down, and then drag it across. And that will find, as you can see, that will actually find minimum. It'll find the turning point, which is the coordinate 7, 5.
Couldn't you find that like without the calculator?
You can find it, yeah, but for the time being, we're only just exploring this stuff. So I just want you to be able to use your calculator as best you can.
So if like you weren't going to use a calculator.
So as you can see, filling that out, you can do all of that, and then likewise, we can then pick from these which one's which. Okay, so it's obviously sort of repeating itself. And then finally, we finally bring this all together because turning point form is not just each one of those things in isolation, it's bringing it all together. This is basically what we want you to identify. This form here is what we call turning point form. And these things, whether it be the number out the front, which makes it wider or narrower, this number in here, which moves it to the left or to the right, and this number here, which moves it up and down, they're all going to have an effect on these graphs. Okay, so clearly you're going to have to fill in all of these, fill in what A, H, and K is, and then of course complete this. So I expect this to be done in about 1.5 to 2 lessons. I think if you really took your time and explored using your CAS, you could take 3 lessons, which will probably end up giving you for this task. Okay, so let me just recap. When you're going through here and you want a new stuff, you're going to be able to need to start a new document. So you're going to go to the home screen, new document, get rid of that. When you're adding graphs, if we're going, if I'm going x squared and I want to add another one, you want to use the tab screen, the tab button to go on to the next one. Let's say we want control, we'll use a fraction tool. I want 1/7 x squared, which hopefully will be a much wider one, which we established before. And likewise, I want to go, let's go 5x squared, which will be much thinner. Okay, then if I want you to try and sketch them as accurately as you can, and I think that you will be able to cope with this well and truly, whether you're in class or at home. Okay, I'm going to stop that there. Hopefully that's enough. I think that should be enough for you to spend those 3 lessons wisely.